Hey there YouTube, Sam here. A lot of you have been requesting a video on how to make the musical floppy drives, and this is that video. You're gonna have to bear with me though. It's the first time I've made a video using Windows, so some of the edits are a little bit iffy. Should mostly make sense though. If you have any questions, leave them down below. Good luck! Alright, first thing we're gonna do is set up the hardware. So here's a list of parts you're going to need. You're going to need, obviously, an Arduino. You can purchase these online. You can get them at a lot of Radio Shacks these days. Next thing, obviously, you're going to need a floppy drive. Now, it has to be a floppy drive with one of the 34-pin IDC connectors. If you don't know what that is, probably your floppy drive's okay. Basically, there are some really old Macintosh drives from way back in the day that have these weird little proprietary, they don't work. So, just any old normal floppy drive. You're also going to need a power supply. I'm using an ATX-style supply for this example, but from what I understand, you really only need 5 volts. So you don't even, which is just the red wire, don't even need the yellow wire. So you don't need a whole PC power supply, but people tend to have those laying around, so that's what I'll use for the example. Also, you need wire. I used Cat5 Ethernet cable. It's color-coded, which is handy, and I had a lot of it laying around. Doesn't matter, just some kind of wire. So first thing we're going to do is hook up the wires to the floppy drive. Now if you look at the back of your floppy drive, you'll see something like this on the back of the drive. Whole bunch of pins. The bottom pins are odd pins, the top pins are even pins. It starts over on the bottom left with 1, goes up above that to 2, etc., etc. The odd numbered pins along the bottom are all ground pins. The even numbered pins on top are the pins that are going to be doing things and activating features. The pins that we're most interested in are 12, 18, and 20. Pin 12 and pin 11 below it are the drive select pins for drive B. Computers have up to 2 floppy drives, floppy drive A and floppy drive B, and there's some weird stuff going on so they can share the same cable. So what you want to do is make sure that if you have a little jumper on your floppy drive, it look like a little tiny jumper, that it's set to drive B. If you can't find a jumper on your drive, it's possible some old drives are hardwired as only drive A or drive B. And what you're going to do in that case is look to pin 14 and pin 13 and just substitute those instead of pins 12 and 11 for the drive select pins. That'll select A. Everything else should be pretty much the same. You can see real light in brown there. Pins 16 and 15 are the motor enable pins. That'll basically spin up the motor on the floppy drive. We don't use that for the music, but I thought I'd throw that in there in case you're using Cat5. Might as well hook it up now. You never know when that motor might be fun later. Pin 18 and the corresponding ground pin 17 are the pins that are going to make the read head step. Every time 18 is connected to 17, the head will step once, either forwards or backwards, depending on the direction pins. The direction pins are 20 and the ground pin 19. I've wired these up in orange, green, and blue, just because it's handy. Again, colors aren't that important, but I'll be using the same colors throughout the rest of the example. Now that we've got the control pins hooked up to the floppy drive, we're going to go ahead and test them, just to make sure everything's all hooked up. And so to do that, we're going to have to hook the floppy drive up to a power supply. Again, used an ATX power supply, it's the easiest way, but you could just use a 5-volt power supply if you wanted to. For ATX power supplies, if you got a motherboard, you can plug it in the motherboard, press the power button, it works that way. If you have just a power supply by itself without a motherboard, what you can do is you can connect the green wire and the black wire, as you can see here in this little picture, and then when you turn the power supply on, that will power on the power supply even without a motherboard. Alright, now that we've got everything hooked to the power supply, we're going to go ahead and test out the floppy drive, just to make sure everything's working okay. Bear with me here, I know it's a little hard to see these wires, but these are the same colors as we were using before. So I have the orange wires here hooked up as the drive select. You can see if you look at the floppy drive here, that when I connect the orange wires, the light comes on. It's probably a little hard to see. Again, I apologize. The floppy drive only responds to input if the drive select is selected. So we're going to go ahead and just twist those orange wires together. And that'll keep the light on and the drive responsive. Next thing we're going to do is connect the blue wires together. Now the blue wire are the direction wires. When the blue wires are connected, the head's going to move forward. When the blue wires are disconnected, the head will move backwards. Now since I just turned it on, you can see the head is already all the way back, so it can't move back anymore. So we're going to hold the blue wires together here. And then every time I tap the green wires together, that head's going to move just a little bit. Once the head gets all the way to the front, it'll stop moving. If I let go of the blue wires and tap the green wires together again, the drive's moving backwards. Again, I understand it's a little hard to see the colors of the wires in this video, but you get the idea. And if you follow the directions up to now, it should be pretty straightforward. You just need to make sure your drive is clicking along when you click the green wires together. Alright, now that we know the floppy drive's working, let's hook the floppy drive up to the Arduino. The drive select pin, as we saw, only needs to be connected to the ground directly below it. So you can go ahead and just twist those wires together if using Cat5, or put a tiny jumper over the pins if you're doing it without wires. The step control pin, number 18, is going to connect to the Arduino on pin 2. The direction control pin, 20, is going to connect to the Arduino on pin 3. Now if you have more than just one floppy drive, the other floppy drives are going to follow that same pattern, but instead of connecting to 2 and 3, the step pin will connect to 4, and the direction will connect to 5. Then the step pin will connect to 6, the direction will connect to 7, and so on. The ground pins, for the step and the direction, can be connected together, but then also need to be connected to the ground on the Arduino. Now this is important because the floppy drive circuitry only detects that a step should be taken when pin 18 reaches the ground voltage. But if the ground voltage of the Arduino is different than the ground voltage of the floppy drive may not detect that, or possibly the floppy drive may decide to step on its own sometimes. That's not good. So make sure that these are connected up. And with that, we've got the Arduino and the floppy drive all wired together. That pretty much wraps up the hardware section, and we're going to move on to software now. So just like for the hardware, we've got a list of software parts. You're going to need a Java runtime environment. I'm using 6. Probably you'd be okay with 5 or 7. So install whatever you'd like, but if things don't go right, you might want to check 6. I use the NetBeans IDE. It makes it really easy to open up the software just because I built the project using that. You don't strictly have to use it, but it's a great IDE. You should check it out anyway. You're going to need the Arduino software. You're going to need the Time 1 Arduino library. You're going to need my Moppy software from GitHub, which has both Java code and Arduino code. And you're also going to need to download the RxTXCom serial driver for Java. Now, I have a version bundled with the software on GitHub, and it worked for me, but that doesn't mean it'll work for you because it tends to be kind of very operating system specific. I'm running Windows 7 64-bit, and it's fine. Other people may need slightly different drivers, or if you're running on a Mac or Linux box, they have RxTXCom drivers for those operating systems. I've got links for all of these in the doobly-doo, or you can just Google search. First step of software setup is to pretty much install all the prerequisites. You can install Java, install NetBeans, install the Arduino software, and get the RxTXCom drivers set up. Next thing you're going to do is open up the Moppy Arduino project from the Moppy folder in the source download. You're going to plug in your Arduino, and then you're going to upload the code. Shouldn't be any modifications necessary, but feel free to take a look, especially if you're not using Arduino Uno. The other Arduinos should be pretty much the same, but there might be some adjustments needed for different pins or that sort of thing. Next, you're going to open up NetBeans, which you've installed earlier, hopefully, and you're going to open up the Moppy Desk project, which is in the Java folder in the Moppy source download. Then you're going to press Run. This is where you might run into RxTXCom issues, if you're going to have them. Unfortunately, I can't give you a cure-all solution here in this video because there's so many different variations of operating system configurations, computers, Java setups, all that. Use Google, use the internet, ask people in the comments, ask people on GitHub. Get it figured out. This will probably be the trickiest part, but once you're past this, everything else is pretty smooth sailing. After the program launches, you'll get a little window that pops up, and you'll get a drop-down menu to select a COM port. Select the COM port that your Arduino is hooked to. This will be the same COM port you used in the Arduino software to upload the Moppy code. Press Connect. That'll activate the bottom half of the window. Press Load Sequence, choose a MIDI file, press Play, and if all goes well, you have a musical floppy drive. Congratulations. A few quick tips for the MIDI files that you're going to be feeding it. Now, you can throw any MIDI file you want into this program, and it will play it, but it's not always going to sound very good unless it follows a few guidelines. Each drive that you have hooked up can only play one note at a time, and it can play any note between the MIDI C1 and B4. So you have 4 octaves, but anything outside of that range doesn't play at all. The first MIDI channel maps to the first pair of pins on the Arduino, so Arduino pins 2 and 3. The second MIDI channel maps to pins 4 and 5, etc. So you're going to want to make sure that your MIDI file has the music you want to play on the right MIDI channels. Generally speaking, putting a little space between the notes makes them come out a little bit clearer on the floppy drives. Things tend to get a little muddled if the notes are all very long and connected.